Yes, we can. All right, Brendan, all over to you.
Okay, thanks so much, David. Thanks for having me. So I'm going to talk about our Stirling engine generator technology, where we can generate electricity from any heat source. So to start with the problem here, the problem we're passionate about tackling here is climate change. And I've shown with this pie chart here, when it comes to reducing carbon emissions, there's a lot of talk about reducing carbon emissions, but there's this sector that's the difficult to eliminate emissions. And that's what we're really honing in on with our technology. So I've highlighted variable electricity, cement, and iron and steel as the industries that have the toughest time reducing their carbon emissions. And so that's the problem. So the solution that we have is a Stirling engine. I've just showed a basic version of it here just to highlight how versatile it is. So that shows it running off the heat from a cup of coffee, just to highlight how powerful it is. What we would do, of course, we're developing an industrial scale model. So our heat sources would be still very general, but things like waste heat, biomass, hydrogen, biofuels, some of which the only way to convert that into useful electricity or work is through a Stirling engine. So the market advantage here is when you look at these industries, and they're fairly big industries, is that they need sustainable and affordable alternatives for the way they're doing business now. But when you look around and you see solar and wind and other sustainable technologies, they suffer from being unreliable, expensive, and they're not suited to scaling in these industries here. So a quick overview of just what these markets look like. You can probably imagine that this technology would be very broadly applicable, but we're targeting here the low-hanging fruit, the industries that really suffer from a severe need to reduce their carbon emissions. And so in looking at the sustainable global steel market, it's expected to reach almost 800 billion by 2031, a prediction from BCC Research. We've got the distributed energy generation technologies, which almost 110 billion in 2021. And we've gone out and spoken to OPG, just had preliminary talks with them already. And what we're doing now is reaching out to local steel and cement companies to see if we can get something like a partnership, a pilot project, or demonstration, something like that. So for core technology advantages, the real question is, if they're so awesome, why aren't there more Stirling engines on the market? And past technology has suffered from low efficiencies and the inability to use a wide range of heat sources. So what we did in first tackling the research problem is to say, why were they so terrible? So we figured that out. We figured out how to make them vastly better, and then we patented that technology. And just as a comparison here, looking at gasoline and diesel engine efficiency, that's the range there. And when you compare our true cycle technology with a fuel that's similar, like say propane or hydrogen, we could get 65% efficiency. The reason this incredibly high efficiency from our engines is important is because it enables us to use lower temperature heat sources. So we're capable of using something like wood, which no other technology could convert that into electricity, and still have an efficiency of 50% of the energy from that wood can be converted into electricity. So I'll go through this fairly quick because I know I'm time limited here, but just sort of to talk about our progress. In 2014 was the aha moment when I was actually in Bangladesh doing a project there. I noticed this diesel engine in the middle of a rice field in rural Bangladesh and was just like completely overcome with how much the world needs Stirling engines, like how much of a global demand there is for this technology. Since then, we got some NSERC funding, the Idea to Innovation program, to pull these ideas out of the lab and make commercial products. Published the paper in 2018. First working prototype was 2019. We incorporated the company Xterra. That was 2019. Then we managed to get some funding for the company from the Department of National Defense. Then our first employee was hired in 2021. Last year, we had our patent finalized in July. We also began work on our most recent prototype, which is our Gamma prototype. And that's the one we're working on now that we think can be turned into the MVP. And also what we're doing now is looking for some pre-seed funding and partnerships for pilots or demonstration projects. So in looking at our team capabilities, it's everything kind of David mentioned at the start there. So our co-founders are myself and Matt. We're both mechanical engineers. Our first employee is Braden. He's also a mechanical engineer. At least he has a management component to his degree. But it's clear sort of what we're missing here. We make up for it with advisors, right? But there is no one on our team that has that business experience or that entrepreneurial experience. So the goal is to raise $500,000 now. We want to increase our speed of innovation cycles and produce a commercial product with that. And importantly, we also want to supplement our team. So looking for expertise in like sales and marketing, scaling hardware, getting it to market, the entrepreneurial side of things. And then a breakdown of that 500, basically 250,000 is our ask from investors, because we've spoken to OCI about the Ready for Market program and think we can match up to 250,000 potentially with them. And so that is how we would bring our total to 500,000. And there's our contacts. Thanks so much. Hopefully I was under time there.